To explain this topic, I have chosen this problem. A simple beam supported by a roller at A and a pin joint at B with a force of 15 kilonewtons. The center is 5 meters from either side. Now what we need to do is find the reaction forces at A and B due to this 15 kilonewton force, neglecting the weight of the beam. To do this, we'll use these three main equations: the summation of forces in the y direction, the summation of forces in the x direction, and the summation of moments around a point. The first step in this problem is converting the original diagram to a free body diagram. Since this is a beam, we can draw it as a single straight line. At A, the roller supports in a single vertical force. At B, the pin joint in a vertical force and a horizontal force. We can label these AY, BY, and BX respectively, with the initial 15 kilonewtons in the center, 5 meters from either side. Now we can begin to sum the forces. So the first summation we're going to do is the vertical direction. So we pick positive as upwards, and then now we sum them to 0. So we have positive AY in the vertical direction, positive BY in the vertical direction, and negative 15 in the negative direction. So we can rearrange this to leave us with AY plus BY is equal to 15 kilonewtons. Equation 1. Now a slightly easier step is the summation of forces in the x direction. So choosing the sign convention as positive to the right, we set up the exact same equation, but this time in the x direction. So there is really only one horizontal force in this problem, so we can say minus bx is equal to 0, therefore bx is equal to 0. Now the final step in the summation of our forces is the moments around a point. So let's begin by choosing the counterclockwise direction as positive and choosing point B to start with. So the moments around B equal to 0. There are only two forces acting around B, the 15 kilonewtons in the anti-clockwise direction, so positive 15 times distance, 5 meters, and then a negative clockwise moment at from AY, minus AY times the distance, 10 meters. So 10 AY is equal to 15 times 5, therefore AY is equal to 15 on 2. Now taking equation 1, AY plus BY equals 15 kilonewtons, and our calculated value for AY, we can calculate BY. So from here, BY is equal to 15 minus AY, bringing the AY over to the right hand side, which is equal to 15 minus 15 on 2, which is of course equal to 15 on 2, which is equal to AY. Thus, taking these values, we have calculated the reaction forces at A and B with AY equal to 15 on 2 kilonewtons, which is equal to BY. Now this will always occur when there is a force directly in the center of two supports with only vertical components calculated.